So I tried logging in with my iPad and my Lappy both, and I think that's creating an issue. So I think I just wanted to use it for sketch, but I think it's just fine. Yeah. Okay. So the question which I asked was, have you guys gone through a system design round recently, and have you faced difficulties in that? If somebody can talk about their experience, I think a couple of guys would be okay. I just want to know, like, what do you guys feel is the hardest part of these kinds of interviews?
Hello, this is Sudipto here. So I did go through a few system design rounds. So actually, I was giving interviews 3-4 months ago. I stopped giving that after my initial experience. So like the primary challenge I faced was mostly in the coding area, but in the system design round, the problem mostly was that they asked questions about like there's no one right answer for a system design question. So they asked questions around scalability and circuit breakers or resiliency patterns. That's where I think I needed more like variations when I wanted to talk about different solutions. So that is the area where I found I was lacking in terms of like one solution doesn't fit all basically. So we need to know different kind of systems, and unfortunately we don't get that exposure in our day-to-day working because it's mostly one domain, one solution. So that's where I thought that I should join some course which will give me more exposure to different solutions for the similar kind of problems.
Yeah. So I think Sudipto, you're right about this. So before I start commenting on that, anybody else who want to share their experience?
Yeah, I have also gone through a system design interview, and there I was asked for the scalable systems, the banking systems, how you will provide. There will be some issue with the partitions and all. This kind of questions were there. One thing I got stuck was like there were somewhere single point of failure. Like always there will be somewhere single point of failure, and there I suggested him to give a routing table somewhere, and according to that he'll check and do that kind of thing. But I don't know if that is possible or not, just given the answer in that way.
Yeah. So I think the experience has been, so this, I had similar experience in the past. So when I was starting off and I had like 2 or 3 years of experience, I did a bit of designing, but I did not do a lot of designing. And as I forgot the name of like the first person who was talking about this. Yeah, so we all would not be able to build all the systems ourselves, right? So it's not possible for me to build all the systems or all the different categories of systems which are currently present out there, right? So what happens is it becomes very difficult for anybody to answer those questions. At any point of time, if you work on a specific side of a problem, for example, I've worked on a chat related problem. So I know how it works and I know how to scale those kinds of things and what you would use. How do you do real-time conversation and things like that, right? So that's an easier side of question for me because I know most of the things involved in it and I've built it like end to end. So I know how to answer those questions. But something else, right? For example, going into a domain like a banking domain where security is of a primary concern and everything needs to be a transaction kind of a thing, right? So that becomes very difficult for me to answer as such, right? But the expectation is from these interviews is anybody who's going to be hired at a level of a senior should be able to understand the requirements, come up with something which is close to a good solution. So I think nobody in the right frame of mind should expect somebody to answer these kinds of questions perfectly in an interview setup where you hardly get like a 60 minutes or something, close to 60 minutes, not even 60 minutes. It's close to 45 to 50 minutes, right? So if you are expecting someone to answer a near perfect answer for any of these problems, which people have spent, like there are thousands of people building Twitter, right? So if I ask you to build Twitter and I expect you to give me a perfect answer, which somebody, which with a team of thousands came up with like a 2 or 3 years of work, that would not be realistic. So It's never the case where the expectation is that you would come up to the perfect answer. But the expectation is on the different side is when you propose a solution, you should be able to defend your solution. So for example, at any place, I say that probably I will use a SQL database or I would use a queue. Then I should have the right reasoning why I would use that queue and how it impacts the design, right? So those kinds of questions, if you're able to answer, and if you're able to basically talk about trade-offs, right? So using a SQL database versus using a NoSQL database. If you know the primary properties of the database which you're talking about, and you say that, okay, X does well in X in these kinds of things. For example, I would just take SQL databases, give few transactions out of the box. So if I'm building anything which needs a transactional behavior, probably I'll go with a SQL database. NoSQL database are more like eventual consistent. So that will not give me a transactional kind of behavior. And for building transaction kind of behavior, I would have to write some kind of layer on top of it or some code and things like that, right? So when I talk about this, right, if I'm able to put this across to the interviewer saying that, okay, I have two choices, but I'll pick this because I think this is the right fit for this. And you can also talk about the other alternative and talk about the trade-offs, right? So me putting out the transaction is probably not gonna be supported well in a NoSQL database. It's a kind of a trade-off, right? So if I'm gonna select this, I will have to build some more code on top of it. So it adds more complexity. So if you're able to talk like this in an interview where you're able to explain your design choices and why did you use this versus this, that's what people are looking at. Yeah. So that's what the primary purpose of these interviews is. It's basically to check the breadth of your knowledge. So do you understand, for example, REST APIs? Do you understand how to handle files? For example, things like you use blob storage like S3, or I think Azure has also have this, like different offerings as such. Do you understand those kinds of things? Can you, given a problem statement, can you think of these technologies which you have experienced in the past and come up with this, that, okay, this is how it's going to look like, and things like that, right? So that's the main motive of these kinds of interviews, right? Now, these kinds of interviews are generally divided into two parts. So design is again like two-phase. It's not a one-phase kind of a thing. Okay, so I think I would. Okay, so before going into that, I would just want you guys to just look at the sets which we have for low-level design and high-level design. So as I told you, right, the design component would have two things. It would be LLD, which is gonna be things like we'll talk about basically some design patterns, a few examples in this, and then we'll have some case studies for high-level design. And this is where I would primarily want to spend more time because I feel this is where people have difficulty actually answering the questions. So sometimes it's not that you don't know how to answer those questions, but you don't know how to drive like a conversation in that regards, right? So in a high-level design interview, the primary expectation is given a high-level statement, you should be able to talk about it, that how you're going to implement it end to end without the interviewer asking you much questions, right? They would basically prompt you or ask you for some pointed questions if they feel your design is not as per expectations, or they want you to go deep into anything. But you should be driving all of these things. You should be driving the whole interview. So if it's going to be a 50 minutes round, I expect a high level design round. You should be speaking for at least 40 minutes as such. And be talking about all the things, using all the tools which you can use, coming up with high level diagrams, talking about the application interfaces, which can be REST APIs, gRPC APIs, or like, I mean, depending on the use case, it can be a server, like a queue worker model or anything it is, right? You should be able to talk about this. You should be able to talk about database designs, your databases choices. Do you need a cache? Do you don't need a cache? And things like that. So it should be something that like you drive this all as together. You talk about all the things that you feel is right in answering that question, and you should be the one basically taking the charge as such. This should not be that after every 5 minutes, an interviewer would ask you, okay, so how would you design the database? What tables would you have? I mean, do you want to cache it and things like that? I have also done like, I've been on both sides of the table, like talking about, I've taken system design interviews as well as I've been into a lot of system design interviews as well. So in those cases, right, I think I do well in those interviews where I have been driving it. And it's always easier, right? You can talk about your strengths. In a design round also, there's a lot of things which you can talk about. If you feel that you're good at databases design, you can probably go into that direction and talk about databases design for a length of time. I would not say don't spend all of your time talking about the database design as such, because then you would not be able to touch on other things. But you can basically spend, instead of spending only 5 minutes, you can spend like something close to 7-8 minutes. So that makes it easier for you that you are spending time on things which you're good at. And if there are any cross questions, you would probably be able to handle it better. So if somebody is good at designing API interfaces, for example, REST APIs or gRPC APIs or WebSocket or anything, right? You can spend time on it. You can basically lay down a structure and do it, right? So always think of these interviews as very subjective, but don't think of them as a hard kind of interview. The thing which is required is just you should know how to navigate through all of these interviews. Okay. Okay. So this is the topics which I'm planning to cover. I'll add a few more. I think the case study for high-level design is still pending. I'm still looking into what's the best one to use. But yeah, this is the high-level thing which you're going to use. Okay, 1 second. I'll go back to the slide. Yeah, so I see that there's a Ashraf has raised his hand. Yeah, please go ahead.
Yeah, Ajit, I wanted to share one experience of low-level design, especially like till now we have heard experiences of mostly high-level designs, but in low-level design, like I was asked to design ATM vending machine, and like in 45 minutes, and I had tried my best to do it, and the feedback was like it was very specific. Like they gave good feedback. Like they told me that, first of all, validation and processing logics are together. And then they told me APIs are not clearly segregated. Third, they told me traceability is clearly ignored. And fourth, initialization of vending machine is added but not clearly separated out.
Yeah. Exactly. So I was coming to the next part, which is the low-level design part, right? So yeah. So answering a low-level design question also requires a bit of work, I would say. So as you said, right? I don't know the exact question, but in a lot of these questions, you would have to basically understand what the problem is about. Sometimes they mention clearly that these are the 5 requirements that we want to use, right? Sometimes people there are also machine coding rounds. For example, if I can name a few companies who stress on this, probably Swiggy and Flipkart have been through some of these rounds. I've seen that they will give you a high-level problem with some basic understanding that I want XYZ requirements as such, and they want you to code it out. So what happens is, now you need to write good code, but you also should remember that your code should be compiling and running in the end, right? So they would basically try to input few values and just see whether it's working fine or not. So you need to do both of these things as such. And the other kind of things, I think you put out a question, right? We'll probably go through this question in a bit. Yeah. Okay, I'll look at this question, Jen said. I'll probably talk about it in a bit. Yeah. So in low-level design, you will have to look through, basically understand, so suppose if I give you something like this, right? If I want to build something like an Ola, where your requirements is there are multiple cabs, there are multiple drivers, a user can come in and request for a cab as well. If this is a high-level requirement I give you, right? A lot of people would be lost as such. They would not be able to understand from how to begin these kinds of rounds. What kind of classes should I create? Where should my responsibility lie? Who should do all of these things, right? So we'll talk about this in this series itself, in the low-level design series. So primarily this includes things like design pattern, which would talk a bit about the structure or patterns of codes which people follow for solving a specific kind of problem. We're going to come to that in probably the subsequent classes. But you should remember this, right? That I've seen a lot of people make this mistake that once they learn a design pattern, they will try to force fit it into a solution. Never try to do that. Understand this point that a problem can be solved in multiple ways. The same thing goes for writing code. You can write and solve a problem via code by different ways. There's no one right or wrong answer. It's just that if you take a choice, you probably are gonna make your code more readable, easy to understand with proper abstraction, or you'll make it hard to, like, you can make it a bit hard to understand. It's hard to debug. It's very hard to extend in the future as such, right? So we'll talk about those things as such. And again, in the end, probably we'll have a few case studies we want to pick, and we'll talk about those, right? Okay. Okay, so before going into this whole thing, right, I would again take a couple of minutes. If anybody has any question or if they want to share any particular thing, right, we can.
So just out of curiosity, Ajit, this is Sudipto here, by the way. So as part of this course, would we also be having some like mock sessions where like we will be asked questions and we will be evaluated based on the response we give to those design questions?
Yeah, so I think good question. I would say, so right now in this whole series, we have planned a few of the case studies out, right? So I would say that if we can squeeze some time in those case studies, probably we would be able to do some of these, I would say some mock interviews kind of a thing. But I would then say it totally depends on the number, right? So right now we are close to 17 people, I would say. It's very hard to do 17 mock interviews, right? So I would say I would try to do that. I would try to do that in a bit, but I would have to see how much time we have. We'll probably do 1 or 2 classes for mock interviews. But again, even in 2 classes, right, I would say 4 hours. It's going to be hard for all 17 people to actually participate, right? So I'll see how to go about this. I'll probably give it a thought. Okay, I see again a hand is being raised. Yeah, Venkatesh, go ahead.
Yes, so my experience, I was based mainly on the networking side. So how the data from we are submitting from the request from the URL, how it's behaving, they will cover for each and every layer, what will happening on each layer. So this type of questions I mainly faced.
Okay. So Venkatesh, I would say that once we're done with the low level and high level design both, so then I think you would have a fair bit of idea of what happens in each layer as such. So I would say that to answer this question, you'll have to go through both of these, because I can just say that the expectations in these kinds of interviews might be that you'd be able to design the API contract, which might be a REST API, or they would want you to write some methods or functions like that. And then probably go into the database layer. If you have to add caching, how would you add caching and things like that, right? Would you use some third-party queuing system or like things like that? So I would say like both of these, right? Once we are done with the high level and low level design, probably you will be more comfortable with these kinds of questions. Okay, I think Shivan has raised his hand.
Yes. From my side, actually, I didn't have experience on low level and high level design also. I have a doubt, like, I started DSA and system design course, but unfortunately in between I stopped DSA. I'm continuing, but I'm running in a low phase. So will it affect my system design classes or?
Okay. Yeah. So I think a lot of people here would be coming after the DSA course, I would say. So yeah. So one thing, I don't think so it affects your ability to understand anything, because DSAs were mostly about algorithms and like efficiencies and codes like that, right? In this, we are not going to talk about specific algorithms, probably a bit here and there, but that would not be like, it's not going to be algorithm heavy. It's mostly going to be coding, not heavy, but coding structure heavy, I would say. So I would basically give you a coding problem or code, and I would ask you to find things like, okay, can you tell me how to improve this code? Or basically I'll code out an example and I'll say like, okay, this is a way to solve a problem. Can you suggest a B way to solve this problem and things like that, right? So I don't think so it's going to affect you in any sense, I would say. And okay, just as a disclaimer on this, right? Don't worry about programming languages, I would say. For this particular series, we might use Java as a primary because I need to run into something, right? I would want you to not just look at the code, but also execute the code. So for that case, I would probably use Java as a reference, but don't worry about this. I would not go deep into any Java specific concepts. It's going to be very high level Java, where I would talk about what are classes, what are interfaces, how do you do inheritance, and things like that. Nothing more than that. And basically all the examples I would share would have all of this. I would not go very deep into Java because I don't think so this is a Java related thing. And just because we need to use a language to write a program and run it, I'll use Java as such. But if somebody wants to know how to do this in something like a Python, C++, I'm not very good at, so I would not be able to say, but I think Java and C++ are more or less the same. Most of the concepts remain same. So I would say like then there's not a lot of need as such. But in Python, I would say if somebody wants to know, I would be happy to. Okay, I saw some hand raised, but I don't see it. I see only Shivan's. If anybody had a question, feel free to ask. I remember that there was one.
Yeah, I was that. Actually, I was just asking, are we going to code throughout the course?
Sorry, I missed that part.
Are we going to code throughout the course, like whatever we were talking about creational patterns and all?
Yeah, exactly. So the plan is that, so most of the people, when they talk about the low-level design, they go very theoretical. And there's a reason to go theoretical because it is theoretical. But I would try to keep it as practical as possible. So I would share some code, I would try to do some live coding, and I would do a mix of both of these so that it's helpful for you guys to follow and you understand this, right? So a lot of time people would just talk to you about, okay, you'll have a interface, you'll call the interface as X and you will inherit in Y and Z from it. And a lot of time people don't understand how will this work in a real world, right? How can you do it in code and things like that? So I don't want you guys to get stuck at that. So we are gonna code. You are gonna see a lot of live coding or sample code as such. So you are gonna get a lot of examples. Okay, Shivan, do you have another question? I see your hand is raised. Okay, I think I answered some Shivan questions. So, okay, so let's move on. Yeah. So, okay, again, another question, right? How many of you guys have been involved in a software designing phase or software development since the beginning of that software? So from scratch, I would say. How many of you guys have done it? If you just put it in the chat, probably +1, I would just want to know. I see 1, 2, 3. Okay, 3, 4, 5. Yeah, so I think a lot of people have there, right? So you would have seen a lot of documents. I would say, have you guys seen documents which says technical design documents, TDD, right?
Yes, Ajit.
Yeah, exactly. Okay, so as I was talking about the documents, right? The TDD actually comprises of two kinds of details. It's going to have like a high level design details and the low level design details. So in this course, we are going to basically cover both of these. So after this course, you should be able to understand as well as write those kinds of technical design documents. So if you look at it, right, a design interview or like a system design interview, or may it be like a high level design interview or a low level design interview. Both of these actually, the aim of this is to basically assess that a candidate, if he or she is able to basically write those kinds of documents, audit those kinds of documents, and basically implement those kinds of documents. So you should be able to do all of those three. Okay. Okay. So now coming to the design phase, the design phase is generally divided into two parts. One is called as high level design or the architecture phase. The second is called as low level design or the details phase. Okay. So basically in a low level design, what you want to do is you want to talk about details. Now these details would be structures like components, classes and things like that, and how they interact with each other. And so if you look at probably if I'm gonna design something like a cab aggregator low level design, right? I would have things like I would have a user, I would have drivers, I would have cabs, and like yeah. So I would these are gonna be my actors for that particular system as such, right? Now, if I want to understand how these components interact with each other, right? Then I would do some kind of detailing. The detailing might be something like I can write something like a flow, I would say like a component design with a flow chart as such. It basically tells you that a user, what can a user do? A user can do things like they can come in and using their app, they can place a request for a cab. What can a driver do? A driver can look at a request and can basically accept that particular ride or reject a particular ride as such, right? So things like that, right? When you're trying to like detail out things like these things or details comprises in the low level design. Okay. And if you want to know like why do we use low level design, basically it makes it easier for somebody who's going to implement it, right? So there are in two ways you can basically go ahead and implement something, right? One way would be that you would basically not think about these details in the beginning and start coding, and then you'll try to figure it out. What I would, and this is a confession I would say, 80% of the times we do this, right? Because we are not really sure about what the requirement is and how the system is going to perform. What we do is we straight away jump into coding or into writing like the whole structure of our application. And then what happens? In most cases, you would go and reach a point that some considerations or decisions which you took are not compatible enough right now, and you'll have to come back and change it, right? So in order to avoid those kinds of things, what we do is we try to think about how the system should perform. And based on that, we come up with a few diagrams, and these diagrams would be different. Like these diagrams can be class diagram. Okay, so I would just say like, if you can look at, like this can be a flowchart. Like it can be something like a pseudocode, or it can be something like using UML, you can write some class diagrams and things like that, right? So using all these three, what we are trying to do is we're trying to capture the requirement. And we're also trying to basically visualize out a solution. So the solution would basically tell you that how the flow is going to be like, right? Yeah. Okay, I see something in the chat. Yeah. So okay, I got from Sushi TDD now project, and probably we all can refer to this, right? Details of all the components involved, how to integrate IP port URLs. Yeah, exactly. So low-level design diagrams, the code flow exception and exceptions handling scenarios, alerting details, design decisions, why we have chosen some components, deployment details, which cloud to use. Yeah, exactly. I would say if you go into all of these in details, you would also have a lot of places where you would talk about how would you handle exceptions. Like yeah, so I see this like the code flow and exceptions handling cases. Right, a lot of time people also use these design to show that if there's a component failure, how are you going to handle it? For example, I use a database or I use a cache, and in general, people don't want hard dependencies on caches, because cache is a good to have thing, right? Cache makes your system faster by basically storing a few things here and there. So I hope everybody understands what a basic cache is, right? Or has a high level understanding of what a cache is. Okay, so I'll assume that everybody understands what a cache is, right? So I would just say that when you're trying to write these documents, you would also try to put in as much detail as possible, so that you are able to put like basically you are able to de-riskify everything, right? So when you write all of these things down in a document, it becomes more clearer to the person reading it. It might be a stakeholder, right? For example, it might be a director or some senior engineering manager who would want to know how are we going to implement the system. So when they read this out and they look at the detailing, right, they understand that, okay, my team or somebody who's implementing this understands how this is gonna, like how they are gonna plan this out, and they have fair bit of understanding of how this is, right? So that becomes easier to audit. You could just come ahead and say like, okay, probably using this particular technology is not a good idea, because this is this is quite expensive for us, and probably we would want to use something as an open source and things like that, right? So you make a lot of decisions. So what you're basically trying to do is, before going deep into coding or starting of a project, right, you're trying to de-risify it by talking about what all decisions you're taking and how things are going to work, right? Somebody can just look at these flowcharts. For example, somebody from a different team, like a product team, and would come up and just say that, okay, your flow would probably not work in the real world because we don't do things like that. Instead, we do things like this, right? For example, your fallback is to X system, and if the fallback doesn't work, then you go to Y system. So we would want to keep it as real as possible. So we would want the software to also implement it, right? So, okay, so I have another question, which I found it really interesting when I was working as such. So have any of you guys tried to bring a new kind of system online? For example, I would just give you an example. So I used to work for an edtech startup back in 2016. And at those points of times, there was not so much of hype about edtech. Right now, there are only two kinds of startups which are mostly in India. One is edtech, the other is fintech. But at that point of time, it used to be quite less. I would say that there were hardly I would say 4 or 5 mostly. So at that point of time, what we're trying to do is we're trying to change our behavior as such. So I'll give an example. The company used to work with schools. They used to provide a lot of content, curriculum, and basically question papers and things like that. Now they want to go digital, and they wanted to use tablets for teachers to teach basically. And now this is a very different behavior change for a teacher, right? I don't know, probably nowadays everybody uses a tab to teach, but at that point of time, it used to be a very big behavior change as such. So when we're trying to basically create the teacher app, we had to face a lot of problems, I would say. The problems were not related to the software, but it was related to our perception of the software. So we used to think that teacher would take attendance. So I belong to a school in which the class teacher used to take attendance in the first period itself. So there used to be a 15 minutes period in which the teacher would come in and take an attendance, and then basically the classes would start. So while building that particular flow, right, I was basically looking at it from that point of view, right? So the teacher, there would be a class teacher assigned to a particular class. If a teacher is a class teacher, they would go to their assigned class, and in the first period or in the 0th period would take an attendance and go ahead with all their go ahead with the classes, right? But yeah, that's an assumption, right? That's not true for all the schools. I've seen a lot of schools who take attendance twice. Once when the starting of the day and once after the recess. A lot of schools do it at the end, when the school is about to finish, probably the nth or the last period as such. So this is where a lot of these documents also help you to understand this, right? So you've captured a requirement assay. So for me, I went out with a requirement which I had in my head. Okay, so there's going to be attendance only once, and probably that's going to happen in the first period or zeroth period itself. Does it work? Probably for a few schools it works, but does not work for a lot of schools, right? So, unfortunately, I got this at the very, I would say, in the mid phase of the software development. So I had to go back and change a lot of code to like add all of these things, right? But if I would have done a design document and I had a flowchart or I had all these requirements mapped out, right, somewhere where I would just say all of this, somebody from the product side or somebody from the operation side who understands these things well, or who has worked closely with multiple schools or multiple different kinds of schools, would come up to me and just say that, yeah, probably this is a very hard assumption and we might not want to go ahead with this and we want to do this, right? So in this example, what we saw that if you have design documents and with proper requirements and things like that, it becomes very easy for, at least not very easy, I would say, it becomes easier for you to understand what you're building, right? If you don't have all of this, it's very hard to communicate with people, right? If I want to show this to multiple stakeholders and I would want to just for them to sign it off, right? Saying that, okay, this is what we're going to build off. And then the other details might be like engineering related details also, right? So they should be able to look at it and just say that, okay, something seems to be off, or you are in the right track, right? So in the low-level design document, I would say it's mostly concerned with the implementation details. But again, if you have put it in some kind of flowchart, somebody who does not understand a lot of engineering would still be able to understand it at a high level. Okay. Yeah, I would just pause for a bit. Any of you have any questions? I would love to answer that. Okay, I don't see anybody asking any questions. Okay, then let's move on. So how do you actually write a low-level design document, right? We call it as LLDD. It's a mouthful. So one way, and this is something like you can use one of these, a combination of these, all of these, whatever you feel fit. There's no hard requirement of saying that you have to do this, or you can only use this, or you have to use all of these, right? It also depends on the use case. In a few of the use cases, probably a flowchart works best. Why? Because it's basically because that's probably a very close representation of the software you're trying to build. For example, if I'm trying to build a workflow management system, which is kind of a flowchart, right? You can represent a workflow diagram, a workflow management software or a project quite well in a flowchart. Like you can represent it quite well, right? So that's a natural fit for it. If you are trying to design things like how the components are going to interact with each other, probably a component diagram which shows how the user interacts with the software system as well is kind of like a good choice for representing those kinds of details as such. So I would say these design documents have multiple ways. These design documents can be written in multiple ways using multiple types of like diagrams, charts, and details as such, right? So the first thing which people generally use is called as flowcharts. I think each one of us would have come across a flowchart somewhere in a school. I think in a school or colleges, you would have been taught a flowchart, right? So what is a flowchart basically? A flowchart is basically a pictorial representation of the decisions which you're going to take. For example, in this case, the example is very obvious, I would say. If the lamp does not work, you just check whether the lamp is plugged in. If it is not plugged in, you plug in the lamp and it starts to work. If it's plugged in, then you need to check, is the bulb okay, or is the bulb working well? If the bulb is burnt out, then you need to replace. Else, if the bulb is fine, probably you know that the lamp is not working well, right? So you probably want need to replace the lamp itself. So this is how you represent a flowchart for a simple lamp doesn't work kind of a scenario. Okay. The next one would be pseudocode. And I think this is also which we have done in the past. People, and there's no, so what is a pseudo, how is a pseudocode different from a code itself, right? So a code is basically going to be interpreted by a machine. So a machine can understand the code. They would be like, the machine would be able to compile it, run it, and do some kind of analysis on top of this. Pseudocode is not supposed to do that. In general, I would say there are languages who support pseudocode also. I mean, you can write pseudocode and they generate you the code itself and things like that, right? But in general, pseudocode is meant to be human readable. So you just need, I mean, you want to represent a logic, or I think in the DSA algorithm course also, you would sometimes you would just go ahead and write a pseudocode without writing the whole implementation, right, or detailing it out in that sense. So pseudocode is the same. You basically want to show that, okay, I'm trying to do this and this is how I'm going to do it. But that's not the detail or actual implementation. So if you, in the left-hand side, if you can just look at it, it's basically like, okay, I'm trying to basically, how do you do it? You begin, you create a counter called as number. You have a for loop in which you initialize the counter as 1 and let it run till 100. And what you keep on doing is you keep on rotating in this for loop, or keep on like looping in this for loop, and you just keep on printing the counter. And once you reach 100, you just print out and just leave, right? On the right hand side, if you can see that, right? The same thing can also be represented in a flowchart, right? So the flowchart also represents the same thing. You begin, you basically create a decision, I would say block, and in which you have a counter, and you keep incrementing the counter, and you keep going to the same loop itself. So the loop, it keeps on looping in the same thing. And the moment you reach 100, you basically come out of the loop and you end the program as such. Okay, so this is a pseudocode. The next is something called as unified modeling language. And this is a trickier part, I would say. It's basically, UML is basically a collection of different kinds of diagrams which you can use in, I would say, object-oriented world to basically represent the software which you're trying to do. And it just tries to do some standardization on the normal thing, right? So it's basically trying to represent. So if you're trying to write a class, so if I have taken a decision that there are going to be 5 classes in this particular implementation, right? What I can do is I can create structure diagram for each of these classes, which tells us about some detailing. Right? So if you look at on the right hand side, there's a bank account, which is a class. And we'll probably discuss class in much detail in the subsequent discussions, probably in the next discussion. But I just want to point out this, that bank account is a class. Owner and balance are its attributes, or you can think of it as like basically the properties of this bank account. And then we have methods, which are methods or functions, which are deposit or withdrawal. So what I'm saying is a bank account can have a owner and will have a balance. And the things which you can do on top of this is you can deposit some money and you can withdraw some money. And both I accept amount as an argument and withdrawal as an argument. And if you want to add more details into this, you can add that, okay, amount will be in dollars or in some currency and things like that. Okay, so this is an example of a structure diagram. The next would be behavior diagram. So as I told you, right, I mean, you can use, like, if I want to show an interaction between a user and a software or things like that, I can use behavior diagrams, which is sometimes called as like component diagrams also. I mean, it depends on, there are multiple names for all of these. I would say don't worry too much about the names. Don't try to memorize these things. Just think of this as, okay, if I want to explain somebody this particular scenario, what's the best fit for it? Can I do something like this, right? So for example, if you look at the right hand side, right, there's a restaurant which, okay. There's a restaurant and we have like 2 actors. We generally call these human-like sensu actors, who basically are going to be users or different users in the software platform. So we have 2 users. One is food critic and the other is chef. A chef can cook cook a food. That's the only primary responsibility for a chef. A food critic can eat food, basically just to taste it and see how it is, pay for food and drink wine. So these are the responsibilities, or these are the actions which a food critic can do, right? So I mean, once you're trying to show a user, for example, if I go back to the example which I talked about, a cab aggregator, right? If I'm talking about a user who's using an app like similar to Ola or Uber, what can a user do? I would say they can book I can keep the user on the left hand side instead of a food critic, and I can say like, okay, they can book a cab, they can pay for a ride, they can look at their previous rides, they can talk to chat support or talk to support and things like that, right? The similar way, there's a driver. What can a driver do? They can basically onboard themselves or onboard a cab or onboard themselves, and then they can accept a ride. They can look at their details, account details, which would be like how much payment I've done in this day or how much payment is due and things like that. And they can also talk to their side of support, which is driver support as well, right? So you can build diagrams like this to properly like communicate to the other people or to the audience that what you're trying to build. Okay. The third is going to be an interaction diagram. This is something which we all of us like generally use, and I mean we've seen this in the past, right? So in this there are two components. There's a computer and there's a server. If you want to check, if a user wants to check their email, they basically log into the computer and they just check their email in a browser or in an app as such. If you want to send any email, you basically send you send the mail to the server. The server would basically reply back with a response that okay, your mail has been sent or things like that. If you want to delete your mail, you basically gonna go ahead and say this, ask the server to delete the mail and things like that, right? So you can see that there's multiple interactions which is happening. There's some arrows pointing left to right, which basically means the computer is asking the server to do something or sending a request to the server to do something. Now there's one arrow which points from right to left, which is basically a response. When the server will respond back with saying that okay, I've done this or I've done that, or if you have a new mail or things like that, right? Okay. Okay, so before going to the high level diagrams, I'll just take a pause. Yeah. I'll wait for you guys. Any questions still here? Anybody wants to know anything?
So I have a question, Ajit. So Sudipta here. So for a LDD question, like in a typical interview situation, would the interviewer tell us that okay, what exact mode of communication they want in terms of LDD, or is it up to us to decide and on the fly draw it and show it to the interviewer?
Yeah. So I would say this is a good question, right? So I would say it depends. So the answer to this would depend on the interviewer. But just to summarize this in a better way, right? I would say most of the time you probably might not be needed to do any kinds of diagrams like these, right? Sometimes you would be asked about like class diagrams, something which looks like this, a structure diagram, something like this. So if suppose I'm going to propose a solution, right? And I say like, I would have multiple classes. I will have a user class. I would have a driver class, and I'll have like a taxi as a class, or like I would create a like aggregator kind of a thing, right? So the moment I say, okay, user class and a driver class, the interviewer might come back and say, like, can you do some more detailing on top of it? So how it's going to look like? So now you have two choices. What you can do is you can either you can just open your ID and start writing saying that okay, class driver, and then you add those attributes and then you try to add those functions. Or you can say okay, yeah, I can use a class diagram to tell you this. So this is how it's going to look like. I can create a driver class and you say that driver would have a name and a cab ID or registration ID and all of those things. So you can do both of these as such. So, and again, I will again go back to my previous statement that a lot of times you would have to take a call. So because not these interviews are not supposed to be very pinpointed in the way a DCA algorithm interview is, right? In a lot of DCA interviews, you would be asked like, okay, you need to do this. So when you're writing the code, you know that if you're able to pass all these test cases, you're good. And if any of these test cases fail, probably you need to go back and debug your code. And people might look at the code structure, but most of the time they are only looking at the output and probably at the complexity, right? Are you writing? So if your expectation was big O of n, are you writing is your algorithm big O of n, or is it big O of n square? Then they'll say probably optimize this more. And you would understand it also, right? So that's very pinpointed in that regards, that you know that, okay, have I done well in an interview? Have I done not that well in an interview? And things like that. In a design interview, it's very different from that. You would have to basically assess yourself, right? So sometimes you have a lot of things in your head and you have the right things in your head, but you're not able to communicate it properly. So I would say, in short, I would just say that if you know about all of these things, right? If you know that you can communicate a particular requirement or a particular thing in multiple ways, you'll have to take a call that at that point of time, what's the right way to do that? They will probably not tell you anything. But if you feel that, okay, instead of verbally talking about it, if I can just go ahead and write this, basically a class diagram like this, right? Is it better? I mean, probably somebody would understand this better, right? Yeah. Does it make sense?
Yeah, makes sense. Thanks. Yeah.
Okay. So I would say that for a lot of these questions, right, it's very hard for you to understand what's the requirement from the other side, right? I would say most of the time you would probably not get exact requirements as such. So you should take a call, and this is where there's a difference between somebody who's good at interviews and somebody who's not that great at it, right? It's all about expressing yourself. So if I want to tell you that, okay, I want to tell you this, right? You should have the best tools to do that. The tool might be a diagram, might be a code, or might be anything, right? So if you feel that this diagram, they want you, like, if I kept on asking you, how do you do deposits? How would deposit look like? Now, you know this, that the class diagram doesn't work here, right? Because I cannot add more detailing to this deposit method here. Then you can just go ahead and say, like, okay, let me do something. Let me use something like this, right? I mean, I could use a pseudocode to represent that. The moment I start writing pseudocode, it would get a bit clearer to the interviewer that, okay, there's some implementation detail in a pseudocode. Probably it's not an implementation, but still there's a detailing, there's some sense of detailing in it, right? So they would understand, okay, yeah. And if they want any pinpoint answers, they would say, okay, how would you handle this? And things like that, right? So I would again say, you'll have to use a judgment, but you probably won't. I mean, they would probably, most of the time, they would not tell you that use a UML or use a class diagram or things like that. You would have to come up with that, okay, in order to explain somebody this, what's the right way to do it. Okay. Yeah, Sudipto, is that clear?
Yes, Ajit. Yeah.
Okay. Yeah, and to be honest, I would keep, like, a lot of the answers which I tell you, right, would be a bit ambiguous and would depend on what you understand better, right? So this is where I say, like, a lot of times these interviews are not to be feared of. If somebody who's good at design interviews, why are they good at it? It's not because they know everything. No, I mean, I would just say nobody knows everything, to be honest. It's just because they know how to use their strength. And if you have some weaknesses, try to stay a bit away from those things, because, so I'll be honest. Suppose a lot of people struggle with a lot of concurrency related problems, right? Because it's very difficult for us to process. Human mind is supposed to work in a sequential manner. We can't do 2 or 3 modes. Multitasking is not what humans are good for, right? And so once we try to understand those kinds of stuff, we tend to mess a bit, right? It's a bit difficult. It's a bit complex to understand how it's going to work out. So if you're not good at it, you can try to stay away from those kinds of things and not go ahead in that direction, I would say. Or if you suppose you're not very good at understanding indexing for databases, or you're not very comfortable with indexing, or you don't know how does Mongo does a specific thing, right? You can probably stay away from those kinds of things and steer the interview in a particular direction where you're good at. So always remember this. You can drive a system design interview, and that is a plus point. So try to do that. But be also be mindful of the feedback that if somebody is more interested in knowing how the database is going to be designed for this, you would have to respect that and you would have to go that, right? So, but yeah, at most times people give you the freedom because they want to understand, like, what is the breadth of your knowledge? How would you do it? Instead of them asking you how would you handle this? How would you handle this? You should prompt them like, okay, I'll do this, I'll do that, and things like that. Okay. Okay. So I would just introduce a high-level diagram. What is HLD in this lecture, class, or discussion? I would say we would anyways in the subsequent series we would anyways discuss this in detail. But I just want you to understand how is a low-level diagram and a high-level diagram different, right? So in a low-level diagram, if I go back, you can see that these are details. These are implementation level details, right? Okay, I'm saying okay, there's a bank account. In this, I'm talking about some users and some actors and what are the actions they can take. In an interaction diagram, I'm talking about how the components interact with each other. Right? In a high-level diagram, I'm taking basically a 100-feet view of how the system is going to look like. And I'm talking about the different components of the system. But in this case, the components might be things like servers, cache, databases, and things like that. So if you look at the example, right, it says, okay, the clients, which is basically the clients might be browser or apps, right? They will hit a load balancer. So the request comes and hits a load balancer. Now the load balancer would basically be redirecting that particular request to one of those application servers. The application servers might contact them a number of application servers because we want to have redundancy so that we can avoid single point of failure. And we'll talk about these things in detail, but just to understand that this basically means redundancy. The application server might contact a database. They would go to the database to fetch some data, get a result back, and then probably again go back the same route to push that result to a load balancer, and then the response goes to the client as such, right? So what I'm trying to do is I'm trying to tell the person who's reading the document to understand, okay, what sort of components are going to be and what sort of interaction it's going to have, like from where the request is going to flow and things like that, right? Okay, so I'm going to leave the high level diagram to this bit for now for you guys to just understand this. I'm just pick up one example. I don't want to go into a lot of details right now because I would say then probably will spend a lot of time on this. We should, right now I'll just leave it to here so that you understand that what is a HLD. And if you look at any diagrams, you'll be able to say like, is it a HLD or is it a LLD and things like that, right? And there are times when people would mix up both of these, right? I can have this diagram and I can add some more implementation details into it. Don't worry about it. There's no convention, I would say, as such. You can use the way you want to, but in general, it's better to save both of these separate so that somebody who's just looking at it understands that, okay, this is a high level diagram. I should not expect a lot of detailing in it. And this is a low level diagram. I should expect a bit of detailing in it. Okay. Okay. Any questions before we start trying to look into some code? Okay. I hope you guys have not fallen asleep because I'm not getting any response from you guys.
We can continue, Ajit. It's good.
Yeah. Okay. I mean, I'll just take a moment and I would just want somebody else to talk about anything which they feel like, because I think I can also use a break. And I'll keep on doing this because 2 hours is a very long time for me to be speaking, right? So I would just want guys to participate and feel free to talk about anything. This is a very safe space. Nobody's going to judge anybody. And you can talk about any of your experiences, right? So as I talked about HLD, right? I would want to know, like anybody who wants to talk about HLD, any interviews they have gone through, any diagrams which they looked at and find odd, or they had difficulty understanding the diagrams and things like that. So, I mean, I think we have a couple of minutes. Anybody who wants to go and who wants to talk about their experience about HLD or anything related to HLD is fine. Okay.
Ajit, I have some experience to share. So I was asked a question about designing a user management system in one of my interviews. Mm-hmm. So which included like authentication management and like the role permission management of the user system such. Yeah. Yeah. So the experience I had it like it is difficult to envision the full system and at the word go. So it took a approach of dividing the functionalities and then like breaking them within themselves, and then building out the entire the component interactions. So I mean, it was a 30-minute discussion, so I think it was not enough to break down all the components. But in that sort of a situation, I wanted to know your feedback on, if we know that it's going to be a 30 minutes session, should we leave the breakdown or focus more on talking through what we will be doing rather than actually like drawing out the components, or should we continue and try to draw out it? I mean, I faced that problem and I could not finish it. I thought later on that I should have not focused on completing it rather than talking through what I was thinking. In that sort of a situation, what should we do?
Yeah. So I would just say, so, okay, just to say, right, it was a HLD kind of a round, right? So did they specifically tell that this is HLD kind of round, or, I mean,
yeah, it was HLD. It was high level design only, but it was a pretty complicated system because user management with authentication management, it's not simple. You have to take care of a lot of things, right? So I was engrossed in breaking it down to the smaller components, like each individual microservice and the database or the caching layers beneath it. So while doing that, like most of the time went by and I could not justify the selection of those components, basically.
Yeah. So I would say 30 minutes. Actually, I'm surprised that it was only for 30 minutes, right? Because sometimes when I am in an interview, right, I generally run out of time, even if it's like a 60 minutes round, right? I would probably prefer a 90 minutes round in those cases, right? And you're right, user management is kind of like is a very deep topic, I would say. If you want to design systems, I mean, there are a lot of things which you can do, right? And there's a lot of things, right? So user management for people who are new, right? Or probably not have dealt with systems like that, right? There's two concepts which generally people use. One is authentication and the other is authorization, right? And as I felt we were talking about it, it's probably like the question included both of this, right?
So, yes, authorization as well.
Yeah, authorization. So, okay. In these kinds of cases, right, which you have only 30 minutes, I would say be explicit. Ask the interviewer for, okay, can you tell me, so because I see that 30 minutes would not be a sufficient amount of time for me to explain this whole thing, right? So do you want me to draw a high-level diagram for this, or and probably so I'll tell you why a high-level diagram always works in HLD. So in an in an interview of like system design interview, right? Basically on the high level HLD kind of a thing, right? You always should draw the diagram, I would say, because drawing the diagram makes it clear for the interviewer. If I'm an interviewer, right, what sticks out from an interview? If I have looked at some diagram, and if you were able to show the request and response cycles, and I mean how the interaction happens in between them, right, properly, right, it sticks to me, right? I'm able to get that, right? Okay, so the person was clear enough in making me understand how the interaction is going to be, right? So I would say always try to do the diagram. Like obviously you would need the requirements first. Try to trim down the requirements. So I don't expect them to build like, as you said, it's authentication and authorization, right? So I don't expect them to, like, you to build a whole OAuth. I don't know whether you guys are familiar with OAuth protocol.
Yeah, OAuth is what I was trying to
exactly
use,
so
but it's pretty huge actually.
Yeah, exactly my point, right? So this is where I would not go into that territory unless asked to, right? I would just go ahead and tell them that, okay, I see there are multiple ways to do this. What is the expectation out of this? Is the requirement to do this is this? How does the permission look like? I can assign multiple. So do you want me to have like a role-based system? RBAC. There's something called as RBAC, right? Role-based attribute control, which basically says that a user, there's a role will have multiple permissions, and you can assign a user to a role. Something like that, right? So I would have taken that approach and basically went ahead with that, right? And if they come back and ask me that, okay, can you do more things? And you can just say that I can go ahead with the OAuth kind of stuff, but because it's 30 minutes and it's going to be hard for me to explain this, probably I'm going to stick to this. And just look at the reaction. If they want an OAuth kind of a representation, OAuth kind of implementation, they would come back to you and basically ask you that, okay, I think you're going down the route of RBAC. Do you know something about OAuth? Let's discuss that and things like that, right? So do this, right? So in any of these interviews, right, even for 60 minutes, if somebody asks me to design Twitter in 60 minutes, I cannot design all the requirements of Twitter in 60 minutes, right? What I'll do is I'll basically list a few of the requirements, and I'll come back to them and say, like, I see this, I have listed all of these requirements. Do you think this works? Should we go ahead and try to implement these set of requirements? Can I trim down a bit or should I add more? And they would again tell you that they will themselves tell you that, okay, let's probably only look at the user activities with that kind of thing, or what happens when you post a particular like a tweet or things like that, right? So they will trim you down for it. So always try to do that, right? The reason people want you to people will not be explicit upfront is they want you to ask those questions as such, right? Because when I'm trying to design a system in a company or things like that, I would have multiple stakeholders. Somebody who would be a primary stakeholder for which I'm trying to build a software. Now I need to come up with those questions to them, right? So that I get my requirements right. They will not build a requirement document, or probably a product team might not have all the requirement documents or things like that, right? So you should also play a part of a person who's able to trim down the requirements and then propose a solution out of it. So I would say that's how you should have approached this. So just curious to know, right? Did you ask these kinds of questions?
No, I think the mistake I did was that I started like designing without much interaction. So I thought we'll come back to it once I start explaining, but I went on breaking down the systems, and I think it was a time mismanagement from my side. So I think I basically focus on
I'll be honest, 30 minutes is very less for this kind of a question, right? But that's the whole point, right? So if you know that this is 30 minutes, I can't spend a lot of time there discussing, right? I would probably not pick up OAuth. I would just go ahead and say, like, okay, I can do authentication and I can do authorization. For authorization, I will do something like RBAC, and I would go ahead and tell them like this. And you can just show them like, okay, this is the component. This is where I'm going to cache the roles and permissions, because they're not going to change much. I'm going to use a cache. I'm going to use a database to store all the roles, permissions, cache. So when a user comes in, I would fetch from the token. I'm just giving random examples for people who are not able to follow. Don't worry about this. If you want to ask some specific questions, it's completely fine. You can ask me. We're not discussing an authorization or an authentication system. I'm just telling in this particular thing, right? In 5 minutes, I'm trying to tell how I'm going to approach this question, so you guys understand what the thought process is like. This is nowhere like a discussion on an authentication system. Right? So if I look at this, right, a user would get a token. The token, when it comes to the server itself, the server would use a token basically to decode what is the permission for that user. Is the user authorized and things like that. And based on that, I would pass this to the subsequent REST API or handler, right? And then you can process it, right? For example, some user might have only a permission to create something, not have a permission to create something, but only have a read permission, right? So in that case, if they're trying to create something, I would come to the handler. I will look at their token. From the token, I would use that token to fetch some details from cache or database. Probably using a cache is better because it will save you some time. You fetch those details, and you basically now check whether has the permission, is the permission to create something there. If the permission is create something is not there, you just return from there saying that 403 access denied or things like that.
Yeah.
Makes sense?
Yeah.
Okay.
I think breaking down for too much further is not required unless some questions are asked around it.
Yeah. So I think you could have done is you could have made us a high level diagram for it, which basically tells you the different components you're trying to take, and you can just give, because it was 30 minutes, right? You can just walk through an example of saying that, okay, so there are two categories. I'm just going to talk about two categories of permissions, which is read and write, just for the sake of this discussion. And I would say a user who has read permissions, when this is how the flow happens. So it becomes easier for you to understand, right? The other user has also like you understand that how the implementation is going to work, which is from where are you going to look at the rules and look at the permissions and things like that, right?
Yep. Mm-hmm.
Yeah. So always try to do all this, right? Give an example of a sample request flowing through the system. If you do that, right, it makes it much clearer to the person that, okay, yeah, the person understands that how a request would flow through it. And if they have something, right, if they feel that something is not going to work right, they would ask you, how do you do this? And then you have a pointer. Okay, the person wants me to go deep into this. Okay.
Yeah.
Okay. So
one more question, Ajit. Will you please take me to the previous slide, that HLD?
Yeah.
Yeah, so here is a load balancer, right? And he have asked me in a HLD round that what if this load balancer will have some point of failure? So basically, what will happen at that moment?
Yeah, exactly. So you're completely right? So load balancers. So any system, there's a chance of failure, right? If it's only one system, it's a chance of failure. No matter how much, I mean, you can have hardware failures, right? At the end of the day, it can have a hardware or a software failure, and that's pretty normal, right? You can't expect anything to work for all the times, like, right? So even in a load balancer, there's a ways in which you can have active load balancers and passive load balancers as such, or sometimes people call it as like hot standby and things like that. So there's a load balancer, but it's not only one load balancer. There's a redundant load balancer which is on standby. So the moment this load balancer goes down, the other would start coming.
But he asked me, like, there is a DNS server, right? Whenever a client requests something, then you have to go to DNS server and he will give you the IP address of the same, right? So he will have the IP address of one single load balancer rather than having multiple, right? So what if that IP address will go down and at the next time you will say that next node balancer will come, but how it will perform there?
Yeah, so
that was one question.
Yeah, okay. So first of all, a lot of times, right, you're right, eventually it gets resolved to an IP address. But the IP address need not be associated with one single machine. It can be associated with another DNS in between, right? So if you think about this, have you guys worked with AWS?
Yes.
ALB
we can use for this purpose, right?
Yeah, exactly. So how does ALB also works? So ALB also has those kinds of like this has standbys and things like that, right? Because again, if you use any single machine, you'll have a problem, right? So as somebody pointed out, right, ALB, we used to have like the classical one is called as classic load balancer or elastic load balancer, and ALB is the application load balancer as such, right? So right now, like a lot of things you can configure on the load balancer itself, right? So instead of having like a single load balancer with a single IP attached to it, you can have a DNS or a domain attached to it, right? Something like XYZ, lb.xyz.com. Now, beyond this, right, once you have this DNS, you can have one load balancer who's basically active right now, and then the other one might be a hot standby as such. So now it's not a problem, right? So what happens is, in case of failure, this load balancer itself, right, there might be some interface in before that, right, which is basically a lot of application load balancers provides some kind of way in which you can configure things like when do you do a switching. So basically, it means that it understands that the load, this particular component, the load balancer would also have multiple components, and the load balancer component, which is basically takes care of handling each of the requests, looks at, okay, is my load balancer, my primary load balancer or active load balancer working well? Is it reachable or things like that? If it's not reachable, it knows that, okay, it's something bad has happened to it. It probably might not be working. Then they can do is they can switch that load balancer to use the secondary or the active standby load balancers to a primary right now and use that, right? So a lot of times, right, like we think of these systems to be one as such, but these might not be one, right? If you look at the application server level, right, it itself, it's the same thing, right? It's not one as such. It's basically a combination of a lot of servers, and the load balancers act as basically the component which helps you handle all of those things. So in the same way, you can look at load balancer as not just one system, but there are gonna be like, they are also redundant, and there are ways in which you can switch over as such. You can, I mean, there are multiple places where you can build a switch over as such, where if anything goes bad with the active load balancer or the load balancer in use, they can switch over to the other one. And we're gonna come back to this in the load balancer when we're gonna discuss the whole HLD thing. We will have a discussion on the load balancer stuff. Okay, but yeah, I mean, if you guys want, I mean, I would not want to go into much details, but if you want a high level, if you have any high level questions, we can talk about. Yeah, I saw some hand raised, so I would. Yeah, please go ahead.
I had a question on that load balancer only, like when the switchover happens from one active load balancer to other, how the mapping gets changed in the DNS, so that or is it that before load balancer, before it gets routed to the load balancer, it actually gets routed to something which actually finds out which is the active load balancer and internally routes that.
Yeah, exactly. So basically, it's gonna work like that, in which the request when comes in, right? So there are two ways in which you can handle this, right? One is you have active health checks on the load balancer itself. So that particular component which is running, and a lot of these, like AWS provides a lot of these things, right? Where the load balancer itself can do active health check of the things, right? Like just think about the same concept, right? The way in which you have a server and you do a health check, the load balancer does a health check, right? Whether this server is still alive or not. The same way you can assume that there's a component which again does that. And this component might be very light and as such, right? And you can again come back to say that what happens if this component dies, right? Yeah, you can come back and say like there's gonna be. I would say that they built a lot of redundancy in that sense, that it generally is supposed to work, and the software which is gonna handle this is gonna be very small, I would say, in that regard. That it's always gonna be like you would have some kind of active standby, and then the chances of it just going down, right? This particular software which is gonna handle this request going down is quite less. But yeah, I would not say it's not possible, but even if it goes down, right, it comes up really fast. So the moment this particular software goes down, it will again, something would spawn up in the backend, and you would find that okay, it come up. So you would get a downtime, but this is one of those edge cases where this might happen. But yeah, anything, I mean, you would end up at place where you would have like some kind of single point of failure. But again, you can configure it, right? You can configure it in some way that okay, if the system goes down, it again, I mean, a new something comes up which basically will be able to handle these things going forward. So in between those times where this particular software is not working, you would have some kind of downtime, but I would say that it would be very basic minimum, and that's not going to impact much. But most of the times, these are resilient enough that it will not have that problem.
Yeah, and target groups are one way of solving this, I think, where you have a group of like servers which are so where they can be hosted in different like zones, right? So that if one zone goes down, the other zone at least remains alive. That's one way of doing it.
Yeah, so that I would say that that comes after the load balancer and before the application servers. So in order to like, I would say so basically AWS has this concept of regions, which is like US has some regions, India has some, I think one AP South region and things like that, right? So what you want to do is if you have all the softwares in one particular region, or if you have all the servers in one particular region, right? If that region goes down, and there have been times when there's been AWS outages and a region goes down, right? Now if the region itself goes down, nothing will work on your side, right? Now everything becomes a problem. So what generally people do is, instead of deploying all of the servers in one region, what they would do is they would deploy one server in suppose US East one in US West one, and one in AP South, one in some other European region, and things like that. So now what happens is, if one of the region's servers goes down, for example, US East one goes down, right? Now again, you have these things, right? So you would get a bit of latency for US users, but yeah, again, it's not completely working, right? You have different fallbacks, so it'll still work as such. Okay, Pradipto, please go ahead.
Yeah, hi Ajit. So I wanted it. It's not more. It's more like a concern from my side. Throughout my experience, I have worked on very narrow areas. So very small amount of design was involved, or maybe zero amount of. So I am totally uninitiated in this area. So what would you suggest to, should I go through some material or like any resources, or like what would be your suggestion to?
Yeah, good. So I would say, people, don't worry about this. So this is what this whole series is about, right? So as I told you, right, first initial set of series is going to be of low level design, which is basically about a more involved coding. The second set is basically a high level design, which is going to have like a lot of different things, right? A high level design is a breadth kind of a thing, right? So I would, on top of my head, I can think about things you would be taught about, or you would discuss about, like protocols, REST, gRPC, web sockets, server-side events. We'll basically talk about these. You need to you need to know about this, probably even if you're not able to code right now, or you would not be able to code about this, you should be knowing about, okay, there's something called as this, and these are the basic features of this. What is HTTP2? What is HTTPS? HTTPS? How is HTTP2 different from HTTP1? What does multiplexing mean? What does the head of line blocking means? So you would be talked about those things so that you are able to understand those stuff, right? Once you're able to understand those things, I think you will get a lot of these as such. So I would say, if you want to read up, I can suggest you a few things. You can read up, but I would say don't go deep into that right now. Let's have this whole discussion, this whole series discussion. And then probably once you have a base and you understand a few things, and if you are interested, you can go ahead and read deep into this. So I will try to cover all of these topics. So load balancer is a topic. So, okay, let me go back and basically and share the, okay, so I don't know whether which screen is visible. Is the presentation still visible, or is it a different screen? Let me check. Share.
It's a Word document.
Your Chrome.
My Chrome is visible, right? Okay.
Yeah.
Okay, so if you can look into this, right? And I'll be honest, this is not the complete topic list. We have done a few, and we are gonna add more few. Like if you look at this, what is high level? So this is where you're talking about like load balancing. This is what we're discussing as such. So in one whole class, we'll talk about this. What is horizontal what is load balancing? What is horizontal load balancing? What is vertical load balancing? And things like that, right? And when we're talking about load balancing, we're also talking about load balancers itself. I would probably not want to make it a very detailed understanding of like how load balancers work, but I would talk about specifically about what are the algorithms which people generally use in load balancers. There's something called as round robin. This is something called as weighted request, weighted request and things like that, right? So we're gonna like cover those things. Excuse me. When you cover those things, right, it will become much clearer for you to understand like what's the high level component as such, and you'll be able to do this. Yeah, Pradeep, go ahead.
Are we gonna configure those things like AWS load balancers and all?
I don't think so. That this course is gonna be about that, to be honest, because that's more. I mean, to be honest, so the intention of this series is to prepare you more on the system design rounds, right? So I don't think so. People expect you to configure until unless you're a SRE or you're applying for a SRE and infrastructure engineer kind of a job. You would get those kinds of questions, right? So we'll probably want to stay away from those kinds of stuff, not go deep into that. We'll keep it to the theoretical part of it, something which you need to understand while answering these questions, right? So, and you should have some basic understanding about load balancers, but yeah, we're not gonna go hands-on.
Okay. Yeah.
I would say that if you want to go on hands-on, probably it would need more than these classes which you have. Okay, is this good? Yeah, I think we have some more time. What we're gonna do is, okay, I would again go back. Now so in between these things, I would basically be sharing some code, and I would be asking you some questions, right, here and there, just for you to keep engaged. But and also I want you to understand things practically. So I want you guys to basically look at the code and like make a sense of it, right? So this is a sample code which I have written. Right, this is a sample code for something like a server or a microservices which has a handler, which basically has few functions like I'm trying to list balances for a user, list transactions, and get some particular transaction details for a user. So you can think of this as a balance API or things like that, right? A balance handler kind of a thing, handler class kind of thing, right? And this is what the implementation is. You can go through the code and you can just look through this and okay, somebody has a hand raised. Anil, yeah, go ahead.
Ajit, can you please increase the font?
Okay. Is this better?
Yeah.
Okay. So Anil, I hope you're not on your mobile phone.
No, I'm using my laptop, but still it was very small.
Yeah. So got it. Then just wanted to have a disclaimer that guys, while joining this class, avoid joining it from the mobile phone because I'm gonna use code snippets and I'm also gonna do some live coding in these rounds. So I want you guys to follow it completely. So probably a mobile screen might not work in most cases. Might not work well in most cases. Okay. So this is a sample code. I would just say don't focus too much on what I'm trying to do here. Just look at this code. And I know that there are a few things which could have been done better. I would want you guys to suggest those improvements. What do you think is not right? And how you could do it. Don't go into logic. There's no logic here per se in it. There's no logical mistakes. And I'm not trying you to come up with any logical errors or things like that. I just want you to look at this code and what is the first thing which you comes into?
Same logic.
Go ahead.
Yeah, sorry. So the same logic we have written for the three methods. It's duplicates,
right? So are you talking about these three lines?
Yeah.
Okay. Yeah. So yeah, you're right. This is basically I'm duplicating these three things here, right? In this place, and in this place, right? Now, can somebody says what's the right approach to do?
It should be the authentication should be handled in one different layer. It should not be in this in the controller basically. So when the request comes, there should be a filter which grabs the request context, and all the authorization stuff should be handled outside the controller.
Okay, so that's probably a more perfect answer, which I probably wanted to come at the end. But yeah, that's the right answer as such. So one thing which anybody, like if anybody does not have understanding, or if I look at this code and I don't know what this code is about, I could straight away comment that there's a problem with this code. The problem is that I have been writing the same code at multiple places, right? One of the the first suggestion would be I should extract these out into a function and I should reuse this, right? Why would you reuse this and why would you not copy paste this? Anybody who wants to take a guess? I know this is very basic stuff, but I want you guys to focus on this because this is what people make a lot of mistake in. So
Ajit, this is because if in future
line of code.
Sorry, I think multiple people are talking at the same point of time. Can somebody raise their hand so that I'm able to pick one? And yeah, okay. So I think Anil raised his hand. Probably Anil, you can go ahead.
Okay, so copying has some consequences. For example, if I'm copying n number of lines and at multiple places, and there was something to be changed. Okay, so I have to change at multiple places. So yes, so my efforts will be more. So there are chances that I may miss some of the logic to be corrected.
Yeah, I think that's probably the right answer. That's the closest answer which I can say. So if you look at this code, right? Again, Anil, did you raise your hand again? Okay, I think web times. Okay, so yeah, Anil is right here. So why would you want to reuse code? That's the question here. So reusability helps you in multiple ways. One, I would say, is it abstracts out a few things. So instead of looking at this code thrice, I could just look at a function called as authorize, right? Authorize user or something like that, right? It makes it much easier for me to look at this code. I've abstracted out this code from my mind, and I know if somebody has written this code properly, it just does what it's supposed to do, right? That's good. That's handled enough. The other thing is when you're trying to modify stuff, you will not have to modify it multiple places. So suppose if I want to change some logic in my authentication, I don't have to do it multiple places, right? I can just do it at once, and it works across the board, right? I don't have to do any. I don't have any problem with that. The thing is, it helps in testing, right? So now, as I have only this line of code, right? For example, 1, 2, 3, 4, 5 lines of code. I'm just writing a test case for this, and it works across it, right? I would probably, while testing all of these particular pieces of code, I can abstract that, like I can mock those authentication layer out itself, right? Because I know that, okay, I've checked this I've tested it separately, and I have an exhaustive edge test case for this. I can probably just mock it out and say, okay, in this case, there's an authorized user. How does it work? I don't have to write these details down, and in that test case itself, right? So it also helps in testing, right? So if you have small, and always think of this, right? The more code you write, the more you will have to maintain it. The more the chances of bugs are going to get introduced, right? Less number of code, less chances of error, and easier to maintain. So always remember this and always use this. So drive principle is something which is quite obvious, and it should come to you naturally. You should look at a code and you just say, like, I feel like there's some abstraction missing. These two components should be able to like merge into one, or should be able to like, and does not seem to be right. I'm trying to force fit it into one. This should come into your head quite easily, and then the kind of code which you'll write would improve a lot. So always try to think on those lines. When you look at a code, you can just look at it and say, like, okay, I've read this code and I feel something is off. And a lot of times, these things are very intuitive. You don't have to read a book to understand a lot of these things. You should just look at it and it should come to you. It should be basically be popping out and saying, like, yeah, this is something is wrong here, and things like that. The moment you get an understanding of those kinds of things, the moment it becomes easy, right? Okay, so you're right. So this is basically to extract out code. When you extract out code and you can write one function, you can just test out that function independently. You can write more good test cases out of it. And then while testing this particular piece of code, you can just mock those test cases out, mock those implementation out, and just use it as you want. So it becomes much easier to test rather than testing everything at once. Okay, at one place. So the other reason to show this example was, as I think Pradipto or somebody suggested, if I'm talking in terms of a REST API, I know a lot of people will not be familiar with it. I hope everybody is, but I'm not really sure about it right at this point of time. But the other point was, as suggested, right, this particular piece of code should go to a different layer. So, okay, let me just talk a bit about how does a REST API work. So when once you have a REST API, the REST API would have some URL saying that, okay, xyz.com/create /users/create. And this would land up into a handler function like this, right? For example, this balances can be a URL something like users/balances or something like this, right? And would that call to the particular URL will land up into this particular handler function. If you want to use the drive principle, or you want to use some kind of pattern in between, right? What you can do is, before that particular request hitting this handler or coming to this handler, you can create another layer in between, which is basically your authentication and authorization layer, which is people call it by different names. Sometimes you would have heard things like authentication or authorization filters. Some people call it interceptors, and like different, like in Go language, people call it interceptors. In Java, I think people call it filters and like all of those things, right? But the concept remains the same. What you're trying to do is you again trying to build again another layer which handles those kinds of requests, so that somebody who's writing the code of the handler need not worry about it. They can just say that, okay, I'm expecting a authenticated user to come, and you can just use it simplicity. You can use annotations on top of this. Annotations are basically saying that @authenticated user, which basically means that this function can only be called if a user is authenticated and things like that, right? So the motive behind showing this example was to understand that this is a design pattern. This is a kind of a pattern, right? People have realized that if we extract out the layer of authentication or authorization from the layer where we handle the business logic for that particular endpoint, it becomes much better, right? It's easier to test, it's easier for people to understand, and it's maintainable as such, right? So people do these kinds of stuff, right? A lot of modern frameworks or web-related frameworks would find you will have these kinds of handler for authentication and authorization. It's pretty common across the board. I think probably all web frameworks I've worked with have these kinds of things. Why? Why did they come up with this? So people looked at the code, they found that this is a good pattern to have, right? This helps you in a lot of different ways. This makes a code simpler when you're writing the business logic and things like that. So what is it? It's a design pattern. I'm not going to say, I'm not going to tell you what category it is, to be honest, but it's a design pattern, right? What is actually a design pattern? A design pattern is basically like a piece of code or a structuring of code or things like that, which people have figured out that if in a particular situation, you implement the code in a proper structure or in a particular structure, it makes it easier for anybody to follow, test it, reuse it, and things like that. That's what this design pattern is, right? And there are a lot of times when you would have that fuzzy thing that does not fit into one design pattern as such, but you feel is the right abstraction which you need to, or it's the right way to do it. That's not wrong. You can go ahead and use that, right? You are going to use a lot of design patterns or a mix of design patterns in your code, or probably you're not going to use it, right? It's completely fine. There's not one way of doing it. Even if I write this code in the particular example which I show you and run this in a server, it works. There's nothing wrong about it. It just works. It works. But yeah, can I do better with this? Of course I can do better with this. And that's where the design patterns help you, right? So it's not about just solving a problem. It's about solving a problem which makes the code easier to maintain, easier to reuse, easier to test, and things like that. Okay. Yeah. So I hope this helps you understand what a design pattern is. Yeah. Any questions? Anybody wants to ask anything on design pattern?
So Ajit, when we'll be running like doing the LLD classes?
The slide.
Hello, am I audible? Sorry.
Yes,
I think the slide is.
Sorry. Yeah. Hey.
Yeah. Okay.
Okay, go ahead. Sorry, I just missed it. I think there was some internet issue.
Yeah. I was asking a question that for the design patterns, are we going to pick up use cases and then like code around it to understand each and every design pattern, or are we just going to discuss the theory part of it?
Yeah. So yeah, you're right. I mean, I don't want to talk too much of theory about a design pattern because then it becomes very boring for me and very boring for you as also, right? So what I'm going to do is I'm going to talk about a use case. So for example, if I'm talking about, so there's something called as creational design pattern, right? Which is basically about creating stuff and how should you create stuff and what's the right way to create stuff, right? So for explaining creating like creational design patterns, what I will do is I will pick up a scenario. I would explain that scenario, and then we will try to look at it and we'll see what's the right way to go about it, how you would do it, and how people do it in a suggested design pattern as well. So we are going to use code to understand all of those. And most of the time, I would not say always, but 80% of times you would look at a code and you would be coding, either I was doing live coding or you would be looking at some piece of code to understand that. So it's going to be like, you are going to look at the code and we would also want to keep it in that form that the code is fully functional in the sense like you would be able to run it and see how it performs. Is that answer?
Oh, yeah. Okay. Yeah.
Okay. Yeah. Okay. So this is basically just talks about what a design pattern. The stuff which I talk about, right? It's basically some programmers in the past have recognized that there's some common problems which each of us needs to solve, and then they have designed a solution, formulated a solution behind us, and everybody is trying to use that. And because it just works out of the box, and it's easier to test and things like that, right? So people just follow that. So we're also gonna look into some of the design patterns, and we're trying to understand this fundamentally. That becomes easier for you to know that, okay, this is a use case in which if I use this, my code is going to become much cleaner, or it's going to become maintainable as such. But I would also want to add a disclaimer. Okay, sorry, Anil, go ahead.
Yeah, so what I was saying, Ajit, that what I feel, what is the best way to understand design patterns, at least to me, is that if I have some component or some code which is functional, and then I try to refactor it.
Yeah.
Okay, so during refactoring, I come to know, okay, earlier the code was also functional, now is also functional, but I have achieved something now after refactoring.
Yeah.
So that way, I think I can understand in better way.
Yeah. So I mean, good session. So what we can do is those examples, right, which I was talking about. Instead of straight jumping into the right design pattern or the suggested design pattern, what we can do is we can try to solve it in some different ways, right? In a probably not in the right. I would say not in the best way, which is which people try to implement this, right? I would try to show you some examples in which you can also do it, and it probably would run and achieve the purpose. And then we would say that, okay, this code, we can do it, and then we'll change the code to something else, which is similar to refactoring as such. And then we'll try to visualize that, what's the difference between this? How is it more helpful? How is better than that?
Yes.
Yeah, we'll try to do that, right? So I'm just, the problem is those kinds of sessions generally take a lot of time because you have to do live coding and things like that, right? So need to look into this whole thing, how we can deliver in the time itself, we are able to deliver it properly. But yeah, I think I had this in mind itself, so we will be able to do that.
Okay.
So the other disclaimer which I wanted to was don't try to force fit design patterns into any solutions. Right? This is the first thing which I'm going to tell you. A lot of times design patterns come to you with experience. So it might happen that initially when you look at a design pattern, you find it completely useless. And that's completely fine. I've been through that phase where I used to find a lot of, and I still don't understand where I would use that kind of design pattern because it's too complex for me to comprehend. That's going to be fine. That's going to be completely fine. Don't worry about it. It's okay. Design pattern is a good to have thing. It's not that you need to use it in every single opportunity which you have. And don't try to force fit a design pattern. If you feel that this design pattern is a natural fit for it, go ahead and use it. Nobody's stopping you from doing it. But just because I learned a creational design pattern doesn't mean that every place where I need to create an object, I'm going to use that. That's where people go mostly wrong. Don't do that. That's not the right way to do it. If you feel that this is the right place where I can use it, yes. I mean, fair enough, go ahead and use it, but don't force fit it. I've seen multiple people doing that mistake. We should not. We should just not create a few more things because you feel that, okay, that's how somebody taught me, or that's how a pattern works. No. If it's a natural fit, then use it. Otherwise, don't. And in a lot of times in the interview, people would just ask you about design patterns. Like, can you tell me about a design pattern? Can you give an example and things like that? Right? A lot of times you wouldn't, I mean, if it's a natural fit, probably yes, go ahead and use it. There are some things which we generally follow as a principle. A lot of times we do it as for extensibility, we'll create interfaces and extend it because tomorrow, if I want to add more functionality, it becomes easier for me to do that, right? That's okay, and that's fine. But using hardcore design patterns, I would say use it when you're supposed to. When you feel it's a natural fit, don't use it. Otherwise, I mean, if you have like, okay, I'm not really sure about this design factor fits into this particular scenario, don't do that. Don't force it. Okay. Okay, I think we've reached time, and I think I've reached the end of the slide, so that's gonna be fine. I'll take 5 more minutes, and I just want you guys to tell me like anything you would want me to, like in the future lessons you would want me to go, like any particular way. So if you want like a code more or examples more or theory more or anything like that, if you have, and yeah, any kind of feedback if you have, like you should more focus more on, like I would just want to use that so that in the next classes it becomes much easier for me to understand like what you guys have in mind. And for system design, right, I would also say that I would again try to share a Google Sheet. I'll share a link of Google Sheet probably in the WhatsApp group itself, with where you guys can post your questions as such. I will try to look at it. Probably I cannot promise that I'll answer all of these and at that point of time, but I just want to look at all the questions, understand where you are facing difficulty. For example, a lot of people share their experience about in an interview I faced this XYZ things, right? Yeah, actual real scenarios where we use design patterns and implement coding for implementation. Exactly. So Sagar, you're right. This is also what I'm going to try to explain, right? I'm going to look at examples, and I'm going to try to pick up those examples which are very real world, because I know a lot of times even in books you would find a lot of examples which are not, I mean, which you will probably not do it in code, or you don't have a hierarchy or like that in code itself, right? So I agree, those kinds of things I would try to keep it as real examples as possible. But yeah, we'll see. For a few, it's very difficult to build those kinds of examples because, to be honest, I've never used that itself, and it becomes very hard to think through all of those. But yeah, most of the times I will try to keep it as real as possible. If I cannot relate to a software, I would try to relate to a real world entity, so it becomes a bit more easier to just correlate and comprehend. Yeah. So okay. Also, can we share some actual examples of solid principle? That would be helpful. Yeah, sure. So for solid principles, I thought of adding that as a particular topic. I would do that. I think in some class I would do that. So we will cover that. So, can we get access to the slides in the classes? Yeah, sure. I'll do that. I'll do this. I'll share this. I'll make this public, and I'll share this in the WhatsApp group itself. So are you guys all on the WhatsApp group?
Yes.
Yeah. Okay, fine. So I'll share the resources there itself. Okay. Yeah. So anybody has any suggestions, please go ahead. Like, I think I can take a couple of more minutes. I just want to listen to anything which you guys wanted better. I have a few real world examples and solid principles. I think I would cover both of these. Anything else?
Mocks, if possible, Ajit, I mentioned in the initial.
Yeah. So mocks, yeah. So
getting a feedback is very important. Like if
no, Pradip, I completely understand, right? But yeah, I think we need to talk about a structure for this, to be honest. So I don't think so. So mock is not a problem for me, and I completely get that we need mocks. The only thing, the challenging aspect of this is like there are 18 people here, right? For getting good feedback, I would have to do one-on-one with each 18 or 18 people with you for an hour, at least, to understand that, right? Or we would want to do it more than that, right? So I think I'll keep this as open for now. I think I'll probably talk to Abhishek, and we'll try to figure out how to do this, right? Because the number of classes which we have planned till now I had to push hard to cover all the topics I want to cover. So I think I'm anyways short of time to cover those mocks. So let me talk to Abhishek and just figure out how we can do mocks.
What is the duration of the planned course right now?
So I would say now I'm looking close to so there are going to be 13 2-hour classes for low level design, and close to 13, not so 26. I think there was something close to 60 or 70 hours of this course is supposed to be 60 hours or something like that, close to 60 hours.
Okay.
I don't know. And I was looking at something close to 3 months to, like, as we have on the weekend, Saturday and Sunday both, right? I'm doing close to 3 months to cover all of these as such.
Okay.
Yeah. Is it okay? I mean, do you
yeah. That's, I want to just know. Yeah.
Okay. Is there any assignments kind of thing to practice? Yeah. So the experiment, I definitely want to do that, to be honest. So what I'm doing is I'm trying to curate like those questions as such. So what we're going to do is, after discussing each of these problems, like for example, creational design pattern, if we discuss, I will give you two questions, which is related to the same design pattern, excuse me, and I would want you guys to implement it. I'll probably, I will try to give feedback as much as possible, or I would try to do is, at some point of time, I would pick some code, somebody's code, and just do a live demo of it, and probably try to talk about what things can be done better, what is good, what is not so good about it. So I think Sushri raised.
Hi Ajitya, I had the same question. I mean, same suggestion that we need assignments. So
Okay.
for example, if someone doesn't know much about HTTP request response, then if they, like, if we all just implement around 10 to 15 controllers, then we'll get a good idea on that. So people who don't know about certain topics,
Yeah,
for
exactly.
everyone, if you can give assignments, at least 5 to 10.
Sure. So I think I'll add assignments to each of these at the end of the course. At the end of each topic, right, or each class, I would add some assignments so people can use. The thing is, I would want it to be, so as I told you, right, though I would probably be using Java as a language, which I'm going to practice around, like the whole course is going to be around, right? But I would want it to be language agnostic, because I know a lot of people are comfortable with Python, and I want, just because you're learning design pattern doesn't mean that you need to learn Java to do that, right? So you'll find ways to do it, and each of these things can be written in any kind of language. There's nothing stopping you from doing it, right? Some things, sometimes a few languages make it a bit more complicated. For example, Golang does not support inheritance. I think there's a proposal for it, but I'm not really sure about this. But yeah, there are ways around to do inheritance in Golang using interfaces which are not real world inheritance, but yeah, you can use it, right? Things like that, right? So yeah, assignments, I would take that as a feedback. I would definitely work on the assignments, and yeah, real world examples of that. Any prerequisite for the next class? Maybe Java setup, or we can do it in any language of choice. Yeah, Sagar, as I told you, right, feel free to use any language which you are comfortable with. So think of these as concepts, not as particular pieces of code, I would say. Don't try to follow it and copy it kind of things. Initially, it might be good if you want to copy and just comprehend how it works. But yeah, I would say don't try to copy and do all kinds of things, right? And yeah, I would say if you want to have a setup, you can have any setup which you want. I probably will do live coding, but I would rather do live. I mean, I would show you some live coding, I would say. Probably we might not be doing a live coding. I mean, any of you might not be doing live coding with while in the class itself, because I don't think so we have that much of time, right? And I don't want it to be a very practical kind of like not practical, but not workshop kind of a thing, right? We'll keep it to understanding the concept and doing it, and we'll see if we need to do some live coding around those things. Yeah. So prerequisite, I would say if anybody wants to read upon something, they can read about the creational design. So next class would mostly be about a OOPS concept, which is basically about class, object, interfaces, inheritance, and polymorphism. I think I would stick to this. I don't want to cover more than this, because I think this would be good enough for the next class. So if anybody wants to read upon those things, they can just go ahead and read upon it. If you don't get time, or if you're blocked on this, don't worry about this. I would still want to teach at a level that anybody who don't have like much understanding about any of these would be able to understand. So that's the motive, right? So it's okay if you want to do a preparation and things like that. Well, go ahead, feel free to do that. But yeah, if you don't get time, and I know a lot of people are working, probably not be able to make a lot of much time. But yeah, it's fine. Yeah. Okay. Anything else? Okay. I think, and then I'll just wrap this up. It's 12:10. I think we are more than 2 hours. I think I've been speaking continuously for the past 2 hours, so probably I think I should prepare more code samples, because I think it would be helpful for my code also. So yeah, from next class we'll probably talk about more about coding samples, a bit more about coding samples. Okay, yeah. So guys, thanks for joining, and have a good day. See you in next class, probably Saturday. I think Saturday, same time. Probably I think you will get it in the group itself, but I think we'll try to keep it into Saturday and Sundays. Or we'll do it early morning, like 10 to 12 works for me, and we'll see.
Ajit, just a question. Like it's a normal question, like about career and all. So you said earlier that you have worked with a startup product-based company, as well as you might be somewhere VMware and all, right? So what you think actually about a startup and MNC? What should a priority?
Yeah. Okay.
At a early career.
Yeah, I would just say that, like, I was trying to avoid this question because this is something which I've been like, a lot of people have asked me this question, and to be honest, it's a very hard question to answer, right? I don't want to put me on a spot where I say that, okay, you should do that and you should do this, right? Because that's totally up to you, right? But okay, so I would try to answer it in a very politically correct manner, I would say, because I don't want to make a choice for you. So when you're starting off, right, or at any phase in your career, right, the goal should be on skills, learnings and skills. The other aspect of it, the money aspect of it, I would not say it's not important. I would say it's important, but a lot of time, money is a side effect of your skills, and at least I believe that as. So I would say go to a place where you feel you will learn a lot more, or you learn more. Just pick that thing. It does not matter. Sometimes the markets would be a bit volatile. For example, right now you would hear a lot of layoffs here and there. At this point of time, if you want to take a more, I would say, less risky decision, and you want to stick to a big company, it's completely fine and it's completely understandable. Because yeah, a lot of, like, we have bills to pay, we have families to take care of, and things like that. So it depends on what phase of life you are. As we said, like, early career, I would say still, and even in early career, you might, when a lot of people might be dependent on things like that, right? So you don't want to disrupt it, and you don't want to be in that phase where you are anxious about your job, right? When you're hearing about a lot of layoffs and you're getting all anxious, like, okay, things have not been working out, like the market is crashing and things like that, right? So I would say it's your call. I would still say chase learnings, learn something new. I would anyways go ahead and say that if you're in a big company, if you're in a very big company, or even in the best of companies, if you feel that your learning is stopped and you're not getting away, I mean, you're not learning much, and there's no, sometimes it happens that you get stuck in a project and you're not able to get out of the project, you're not able to get to a new project, or sometimes something is not working out. It's fine to leave a very big, well-known company for a startup or a smaller company or something different. Because as you all said also in the beginning, right, a lot of these design questions, not everybody has worked on all of these problems or all of these types of problems. For me also, it's true. I've worked on a few sets of problems, but I've not worked on all of these, right? How do I know about a few of these problems is by talking to people, understanding how it is done, reading a few blogs and doing things like that, right? So that's also how you can learn. And the other way is put yourself in that situation. For example, if I'm somebody who's interested in understanding how chat works, I would look for a chat company and I'll try to interview them. If I get it, I get it. And I try to build a chat system and I look at how do they scale and things like that. Right? So I would still say startup versus MNC or a big MNC, it's a very personal decision, I would say. And it depends on where you are in the stage of your life as well. So I would not say that something is right or something is not wrong or things like that. It's up to you what you want to choose. The learnings would differ. The hours would also differ. Startups are generally tend to be more hectic. MNCs might be a bit not that hectic. I mean, sometimes I know people from a lot of different companies, and my friends, and nothing against them. They've been like working for the past years. When I asked them like, what do you do and what is your one good contribution to a project in the last years, they would not be able to talk about anything. Right? So I have nothing against them, to be honest. I would not say that they're not doing well in life or things like that. There's nothing against that, but that's how it is, right? So they might have a different preference. For a lot of people, this is just a job. There's not a lot of passion and things like that, and then it's completely okay. Somebody who just wants it to be an easy job and things like that. So I would say, look into it as a decision which you want to make. Like, it's completely fine if you want to choose a startup or if you want to choose MNC. Generally in startups, you'll get to learn more because you're going to take more responsibility, but it's also going to be more hectic for you. MNCs, yeah, I mean, most of the MNCs are going to be laid back. You would already be working on a project which is already built to make the delta changes. Probably understanding there would be to understand the code and things like that, or read documents and things like that, right? So a lot of things I would say would differ. Don't worry about it. I would say whatever you feel is the right thing to do, you can do it. I would just say, look at the risk reward situation and look at the macroeconomics of the environment. It's fine. I mean, don't worry about picking a startup or like things can go wrong, but I mean, you can fix it, right? It's just an interview. You can again go and give an interview and get another job as such. That's not a problem. Sometimes it just gets a bit more competitive, that there are less number of jobs in the market, and then you have to fight through a lot of candidates to get a job. But I would just say it's okay, it's fine. I've never seen good candidates going jobless. To be honest, I've not seen anybody getting jobless, at least in the software industry, who's good. Yeah, average people might suffer a bit. People who are below average might suffer a bit. But yeah, nobody goes jobless if they're good. So don't worry about it. It's your problem. I hope I answered this question. I don't want to answer you a question with saying that you should go and do this and you should go and do that. I'm just
Actually, I'm also concerned about the job security, and that's why like the layoffs and our like recession is coming. Many of the blogs are saying in that way, and that's where I just thought like if I join some startup, like it's a music startup kind of thing, 2005, built in 2005, and have good knowledges and all in that. Those kind of people are there, and you will have good learning. But the only thing I feel there is like work-life balance will not be there, and there will not be job security. I guess like
yeah. So you're right about those things. And by the way, like if a company is there from 2005, I think we probably should stop calling it as a startup. I think the term startup is used. It's not used in the right sense. I think after 4 and 5 years, you should not call any company startups. If they're 5 years old, I mean, they're no more a startup. Right? They've been doing the same. They've been doing things for more than 5 years, right? And then they're not starting up, right? In fact, if you look at 2005, it's close to 17 years. Do you really want to call a company who's 17 years old a startup? I don't think so. But yeah, that's nomenclature. Yeah, but you're right. So I would say that right now there's a lot of uncertainty in the whole economic market. I would say there's a lot of things going around, and this is nothing. I mean, a lot of these things are not in your control, right? If the economy is not doing well, like everything gets affected as such. If the inflation is high, everything gets affected. So I would say, yeah, you can look into it. Yeah, I mean, depends on your situation. If you feel that it's a risk worth taking, you can go ahead and take it. But if you feel that, yeah, I'm not going to be comfortable. So this is what also happens. You might join a job, but you are anxious every day. But yeah, I don't know what's going to happen. Am I going to be laid off? Or is my company not doing well and things like that? So I would say take a break. It's okay that, I mean, you can delay your decision by 6 months, 12 months, until you get it right. It's going to be fine.
Yeah.
Okay. Yeah.